working? I think my last stream was set to private. Okay, it works now. How nice of them. Does the screen work? Whoa, why are you not working? Is it working? Let me check. What the freak? What's going on? Am I live? Am I not live? Oh, I am live. Okay. Alright, chat. Today we're doing some reading. Maybe some work as well. We're up to cross compilers. They're just compilers that compile stuff on one platform, but it's compiled for a different platform, so it doesn't include headers or anything else that might not exist on your second operating system. Okay. Oh. Alright, so we're building a cross compiler here. Yeah, we're using GCC. Whoa. There we go. Alright, how'd I pick the latest minor release? Alright, so yeah, let's not use different versions. That makes sense. Older releases. Yeah. Okay. If you want to use an older major GCC release, put a cross compiler of a newer GCC release. The new GCC will be able to, okay. I want to use the latest and greatest GCC as your system compiler first. Okay. Official instructions for building GCC. Let's turn this back. I'll read that later. Compilers are upgraded by bootstrapping. You have your old system compiler that produces code and doesn't support. Then you use this old system to build the new system, hoping that the old compiler is able to build a new compiler. Since a new compiler supports new features, compiler is so slow. In addition, the new compiler may be buggy because your old compiler was buggy. So the next step is to use your new slow compiler. The next step, you use your new slow compiler. The next step, man, I can't fucking read. The next step is to use your new slow compiler that produces fast code and build the new compiler again. Okay, so I've got like GCC 4. I compile GCC5 with it, and then I compile GCC5 with GCC5 again. This produces a fast compiler that produces fast code. However, the first compiler we built could be buggy, or maybe defective. Okay, so the problem we built the compiler. Okay, this seems a bit roundabout. So we build the compiler, build it, and then build it. Once we have built, it should produce the same output as the first compiler building the second. My build system will then verify the second and third compilers are identical. Second and third, then they have failed and there's a compiler bloat. Bootstrapping takes 3 times as long as it is just building a regular compiler, but make sure your tool chain is stable. I mean, fair enough. You want like a working compiler, right? The last thing to do is to run the compiler test suite, so you can see if it works. Yeah, fair enough. 4.8 to build the GCC 4.8 cross compiler. Do I need to bootstrap? What is bootstrapping? What is bootstrapping? System compiler is the same major version as the compiler version you want to build. You don't have to bootstrap. Oh, I'm retarded. Just bootstrapping. It says it right there. Bootstrapping is when you compile a new compiler with the old compiler, and then compile that compiler multiple times. Fair enough. My releases are very compatible. And likely each major release is always able to build the next using a bootstrap. If you have the patience, it's possible to find a Linux system of a very old GCC release and then bootstrap all the way up to recent. Yeah, fair enough. You may be able to upgrade your system compiler through other channels. Jeez. We're on 14. How old is this article? Where does it say that? No, never mind. Latest compiler release. I'll see these other releases. So if your local system compiler isn't terribly old, you may wish to save yourself the trouble and pick the latest minor release. Well, I just use like 12.2 and stick with that. Okay, let's see Ben utils. Okay, 2.43. GNU election, Unix Lite environment. Yeah, I know that. Yep. Do I have GMP? MP for real. Yeah, fair enough, I've got it. Tax info. Never mind. Oh. What should not even exist? Oh, I already have it installed. Okay, blah blah blah. Alright, CDL. I'll just keep everything here. Well, I should probably tools, right? And then what the freak? You ship its own patch. You see, you may. Fair enough. So basically, where's the version stuff? Where I was talking about the versions. Why do I need to bootstrap? Cause so I'm here choosing which compiler to use. Oh, we're on the same page. Okay, let's go to mirrors. That's a lot of words. It's a lot of files. There's 14? Am I not on 12? That's crazy. What is a major and what is a minor release? Alright, so let's probably stick with 14.2. Fair enough. Or should I stick with 14.1? Who knows? What the sigma? Roughly the same time, so what is 14.1? 240507. 24. Why don't I just use the same numbers? 43. There got so many words here. It's crazy. XZ, GZ. What's the difference? What is the difference? What is the difference between tar XZ? It's like gzip and something else, right? Yeah, they're different algorithms. More memory and time. Okay, now we use XZ then. We get. And then where is this? Copy link. Wait. We get. Oh wow. Never mind. That explains why. Let's go here. RM index. Copy link we get. Alright, nice. Let's read some of this first. So we get the source code. Patch GCC benutils. You might not be able to build a new system compiler. Yeah, well, that makes sense. Try newer GCC release, we have the patch source code. Gen 2, I'm not Gen 2. I'm not Mac OS. I'm not Windows. I'm not BSD. Yeah, that's fair enough. That would be a bit scary, isn't it? Should we install globally? Well, I'm doing it in this project folder, just in case. Please note that we build everything out of the source directory tree. What is this? What does this say? Download the source code. Blah blah blah. You build a tool set running on your host that can turn source code into object files. That's a lot of words. Fuck. This kinda sucks. Can't I like learn this through like YouTube shorts? That would be much nicer. Oh well. Maybe I should make YouTube shorts. You decide where to install your new compiler. It's dangerous to replace. Yeah, fair enough. It's just for me. Install it to home opt. Good idea. Install user local. Yeah, fair enough. Out of the source directory tree. Whoopsies. I mean, ay. Alright. Let's, I thought you were supposed to open vertically. Do I do that on streamer? I do this in VM. I get tools. Not media, not home. I want this to be global between my personal account and my streamer account. So probably, do I even want to make? I can have a projects folder. I can make a projects partition because I'm running LVM. But do I? Then I'll have to set up permissions and stuff. What the freak? Chat. Am I cooked? Chat. Alright. Wait, can't I just do that? Silly. Okay. Alright. Whoa! I'm doing 16 because I'm awesome sauce. Export prefix. Okay. This is just like Gen 2. Make dash J 16. No, let's do J 14. Uh-oh. Oh, it's supposed to say prefix, not prefix. Prefix. Is there no make file? Make. JN. Yeah, but there's no make file. /compile. Help. Oh, they want make files here. What's going on here? Okay, maybe I should make this on my streamer account so that if my streamer account goes bing bong, that's okay. Opt. Right. VGCC. Whoa, slash opt. Yeah, fair enough. I don't think this is me. What the freak? I'm pretty lost here. Wire. Kinda sleepy. Am I dumb? What's going on? I feel slow. Like, hmm. Disable? I mean, oh, it's one word. What does this do? Would be nice if they told me. Make the dash J12. Whoa, my CPU usage. That's a lot of cores. Anyways. Not to include native language support. How nice of them. So basically we take GCC. What does this do? Well, binutils is my linker, right? Because LD is a linker. I don't know. Make install. I probably shouldn't have root on this account. Fair enough. Whoa. I don't think this is supposed to be here. Believe me or not. libconv. Man, I'm so lost. Maybe I should read this. I don't really feel like reading it. Womp womp. Womp womp. Oh! I should have downloaded my source code in source and not the other one. Silly me. Do I have gump XYZ? No, I don't. Do I have nothing here. Gump. Dev gump. No, I doubt. I feel slow. Like, I feel dumb. But you know what? You gotta feel dumb to be able to learn. Let's read this again, because I might have skipped a lot. Yeah, I understand that. Oh, I wasn't. I was just reading the introduction. You know, maybe I should read the other stuff before doing any of this. It's a very good idea. Well, I probably shouldn't have deleted that because I'm probably gonna have to reinstall that, but you know, it is what it is. Let's read how the kernel, the compiler. Oh yeah, it's supposed to be a reading stream. It's supposed to be education. Not supposed to be doing anything. I have won by knowing that a cross compiler compiles code for a different system. Kernel is a form of operating system. Memory management, I/O, and rep handling. Other things. Yeah. Don't care. Kernel makes its services available for system syscalls. Oh, I didn't mean to right click. C library. One thing up front when you do not have a C library, you have to provide everything yourself. Yeah, I mean that's pretty fair. C library standard C functions. Oh, how nice of them. Wait, I gotta have to import it myself. Silly me. Kinda wanna write my own C library. That would be fun. Well, I'm probably gonna write my own malloc in the future. C library implements the standard C functions. Provides them binary forms suitable for linking or user space applications. In addition to standard C functions, C library implement further functionality which may or may not be defined by some standard C libraries and nothing about networking. Oh yeah. Fair enough. Know that in order to implement functionality, it was called kernel functions. So I have to take a ready-made C library and just recompile it. But we need to tell the library how to make kernel functions. So I want to write my own kernel. I gotta go, hello C library. Did you know that syscall1 with EAX1 means exit? But actually, I'm on RAX. Okay. Stop yapping, buddy. Yeah, fair enough. Assembler takes plain text source code, turns it into binary. Yeah, fair enough. Oh yeah, it does. And then you have to link it yourself, right? It turns it into like an object file. Additional information like symbol names. The compiler takes higher level language source code, like C, turns into object code. Oh yeah, but then GCC turns C into assembly, and then you use the assembler from assembly into an object file. Object code includes information like symbol names, relocation information. Doesn't contain code for standard functions, so if I include standard IO and use printf, the object code will only contain a reference stating a function named printf exists, and taking a constant char character, char. Do you say char or car? Because it makes sense in the idea that it's a character. You don't say character, you say character. Character. But char sounds nicer because it's like charred meat. You take a string, okay, buddy, and a number of unnamed arguments as parameters. Yeah, so the object code just tells the thingamabob that there's a function called printf and it takes in a constant, it takes in a string and some arguments as parameters and must be linked to the source code in order to receive a complete execute. Yeah, so you gotta link LD, bada bing, bada boom. Some compilers. Oh, that makes sense. So when you compile assembly, you use NASM to turn it into object code. Then you use LD to link it back with the system headers and other shit, so that my things actually work. That's nice. And that's why you can also do that's why you can also compile with NASM, have a reference to printf, and then link it with GCC. Because GCC gives that printf library. Okay, clever. Now I get it. Some compilers use standard library functions internally, like memset, even though I didn't. Yeah, I have to implement. What? That's not very nice. So they use standard library functions even when they don't have them. So we gotta go, hey buddy, you do have them, even though you did not include the header or use the function of this name. Yeah. GCC freestanding environment expects the function memset, memcopy, memcompare, and memove. So the libgcc library. Some advanced operations. 64-bit division on a 32-bit system may involve compiler internal functions. Okay. A linker. Linker takes the object code, links it against the C library. Yeah, that's what I said. And whatever library I choose, linking them to a static and dynamic. Oh, that's new. When linking statically, the linker is involved during the build processors just after the compiler assembly run. Oh, so that's why I talked about. I did static linking, where you use NASM to compile object file. You then use a static linker like LD, takes the object code, checks for references, and then checks those references against the library and then adds binaries. Very clever. That's pretty cool. And after this process, the executable is complete. On the downside, the executable can become quite large. Whoa. Big chungus. And code from the libraries is duplicated over and over, both on disk and memory. When linking dynamically, the linker is involved during the loading of an executable. What does that mean? What does loading an executable mean? Like when you run an executable, it loads it into RAM? Is that what it means? So then when it gets that reference, it goes, hello linker. Linker, what is printf? And then linker brings that out and gives the binary to it, and it runs the binary off printf. Let's see if I'm right. The unresolved references in the object code are resolved against the libraries currently present on the system. This makes the on-disk executable smaller and allows for in-memory space. Same strategies as a shared library. On the downside, the executable becomes dependent on the presence of the library it references. If the system doesn't, okay. So I guess that's right. The unresolved references in the object code are resolved against the library presently on the system. I think I love that midget. Shared libraries. A popular strategy is to share dynamically linked libraries. What the freak? That's a DLL. DLL file. Uh, what was I saying? You share dynamically linked libraries across multiple executables. Oh, so that's kind of how the Windows DLL also works. You have code, and then when you run the code, it runs stuff off the DLL. It's like, oh, okay, fair enough. I should delete my Windows setup. I don't play games enough. Like, yeah, I don't think I do. I can run Brawlhalla and Stardew Valley on Linux, and that's more than enough, right? Like, that's all a man needs. I love Brawlhalla. Where was that? A popular strategy is to share dynamically linked libraries across multiple executables. Instead of attaching the binary of the library, you shared libraries across multiple okay. So instead of attaching the binary to the instead of attaching the binary of the library, the executable image, the references in the executable are tweaked so that all executables refer to. Okay, so like, I think this is what they're saying. So we have the memory, we have our DLL, and then we have our program. Then we have another program, and when it calls printf, what the fuck am I writing? Printf, it goes in the binary. It references that maybe OXOO has the DLL, so it goes to there and it goes, "Hello DLL, DLL, give me printf," and it goes back. And then they're shared, so program 2 also calls printf, and it goes there. Whoa. Whoa, what the freak. So attaching the binary there. Yeah. So the actual code in binary tells them to visit the memory address. Very cool. The library must not have any state, stack, or global data. Yeah, that's true. I didn't think of that. I must provide a separate state for each executable. Ooh, tricky. In a virtual memory environment, it is impossible to provide the library to all executables. Virtual memory environments usually impossible to provide a library to all executables at the same virtual memory address. Library code and arbitrary virtual address requires library code to be position independent. Okay, don't care. Application binary interface. I'm drinking boba and I don't want to chew because then you're gonna hear. So I'm gonna mute my mic. Bro, I almost stopped my stream. I went to like unmute my mic on OBS. I saw like the big blue button and I went on autopilot and I almost clicked it. Application binary interface. Library function calls and kernel systems are done. Oh. So it's like a thing that tells how you call library and how syscalls are. So like if I'm in x86 64 and I want to exit through a syscall, it's probably this thing where it reads EAX being 60 and then goes, hey buddy, application binary interface here. Um, fuck you. And then it exits. No, it doesn't go fuck you and exits it. Um, it checks if the ABI, presumably. ABI tells it it's an exit code, so it exits and then it pulls the value of RBX. Or is it RDI now? I know in 32-bit, if you want to exit, it's EIX is 1, EBX contains the exit code. Okay, enough yapping. This includes whether parameters are passed on the stack or in the registers. Oh, that is smart. Fair enough. So like, oh, so like in x86 you pass the parameters in registers. So if you want to print in x86 64, you put EAX to 1, EDI to standard out, which is 1, and you do other stuff. Okay, that makes sense. How function entry points are located in binaries. I don't get that, but I'll figure it out later. Then using blah, 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 blah. When using static linkage, the resulting executable depends on the kernel using the same ABI as the executable. Huh? 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 The resulting executable depends on the kernel. Oh, yeah, so when you link statically, the kernel needs to be running the same ABI, or else the kernel will think one thing for syscall, but actually it's trying to do another thing and doesn't work. When using dynamic linkage, the executable depends on the library's ABI staying the same. Fair enough. Unresolved symbols. The linker is the stage where you find out about stuff that has been oh, that's not my problem. I should read that and not skip over it. It'll bite me in the ass later. Yeah. So that they're not actually set up, or like, yeah, fair enough. Alright, that makes sense though. So sleepy. I don't think I'll be using other languages than C, I'll be honest. Like, kinda wanna write C, because C's pretty fun to write. Blah 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 blah. Well, can I write a compiler? That's silly. I mean, I do want to write my own compiler eventually. I'm just reading this for fun. But I dropped my roll of tape. That's a lot of words. Oh, it's not that much. Oh, that's a lot of words. Okay, is this a tutorial? Hmm. I'll probably stop the stream when I hit an hour because I'm a bit sleepy and I might do other stuff like work on another side project and get distracted. And I'll start a different stream. Uh, Alright. Yeah, if I. Man, this is kind of fun, you know? Do I really want to? I'll read the BIOS first. I mean, okay, real talk. I can just use the BIOS. Like, I'm not gonna install my OS locally. Cause, like, I'm not gonna use it. And, like, if I were to use my own OS, I wouldn't. But if I were, I definitely wouldn't be using my first copy. Like, okay, yap alert. Stop talking. BIOS. Generalize low-level services to early PC. Yeah. Hide as much as possible. Sleepy. The goal of BIOS is to offer low-level services to PC system programmers. You want to hide variation in PC models and hardware. Yeah, that makes sense. Make OS and application development easier because of BIOS service. Yep, fair enough. BIOS are still being used. Name BIOS functions in real mode. They can be accessed through software interrupts and assembling language. Access the BIOS, you must set the AHCP register. Oh, does it boot in 32-bit or 16-bit? Ah, wire. I did this before. I wrote hello world. EAX. What was it? 4? EAX 4. Alright, set the AHCP register value and do it in opcode. Value in AH combined with the particular interrupt number. Select the request BIOS function. Other CPU registers holding arguments to a function. Is simplest to create a listing of BIOS functions by specifying the interrupt number. Listing a BIOS function by specifying the value of AH. That selects a function. It is also easiest to refer to particular BIOS functions. Hold up, my girlfriend's calling. Alright, so if we want to create a list of BIOS functions, you make a list of BIOS functions by specifying the interrupt number.